right, let's take a look at section 5.4, which is solving radical equations and inequalities. And in our lesson today, or in this section, we're going to split it up into 2 days. The first thing is pretty much all about solving these radical expressions. All right, as it says. So, um, we'll talk about extraneous solutions just briefly right now, but solutions you find, but is not true when plugging back into the equation. And typically, we're dealing with extraneous solutions when we have, um, I guess, fractional equations or rational equations, and also when we're dealing with radicals, as you'll see in part 2. So how do we solve radical equations? Let's go right here to the core concepts. Basic generic 3 steps that they give you here is: one, you want to isolate the radical on one side of the equation if necessary. All right, so that's just like, what is it? When you're solving an equation, you always want to get x by itself. And what ends up happening is you have x in the radical, so that's why you need to isolate the radical in these problems. Step 2 says raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So if you're square rooting, the opposite of square rooting is to square both sides of the equation. Think about when you had to complete the square. All right, at one point in time, you may have had to do the opposite of square rooting, and that's to square both sides. All right, so that's going to be the same thing right here, or the opposite of squaring is to square root both sides of the equation. All right, so that's kind of the idea that we're dealing with right here. And in step 3, you're going to solve the resulting equation using techniques you used in previous chapters. And bottom line, you're going to solve things out. However step and method you take, that's up to you. There are some methods or some steps that'll be better for you to take because you're going to, if you don't, you got to kind of think about it. You're going to have to observe the problem and maybe do some mental work where, is it better for me to multiply both sides or to divide both sides or add or subtract first? And then that'll make, depending on how you go about it, it'll be a lot easier doing one way than the other. One of the things that I recommend is you should always add or subtract first to both sides of the equation before you multiply and divide. Typically, that's going to be the case. Okay, not 100%, but I would say 95% of the time when you work on these problems, you're going to want to add or subtract first to both sides of the equation before you multiply, divide, or do anything crazy like that. So we're going to take a look at several different problems today, different scenarios to get you familiar with what to do when you encounter these types of situations. And there's no like one size fits all. So you may see other problems in your homework that are similar to it, but you can't really perform the same exact step in order to get your answer, right? And that's something you're just going to have to, you learn the more you do the problems. All right, let's take a look at number 1. So we have the square root of 1 minus x is equal to 7. So right here, the radical is already isolated, so step 1 is done. Step 2, it says raise the side of each equation with the same exponent to eliminate the radical. So right here, to get rid of square root, what we end up doing is squaring both sides. And then so step 3 is solve it out. Well, when we square the radical, all we end up with is 1 minus x. 7 squared, 49. Okay, so now we go ahead, we start, we'll subtract both sides by 1, and then we'll end up with 48. And then finally divide both sides by 1, and x is equal to negative 48. Now, it says right here to check your solutions. it's important for you to check your solutions because of what we talked about as extraneous solution. The reason being here is this: we want to make sure that everything works out and is true. So 1 minus, right here, negative 48. Does that equal 7? 1 minus negative 48 is 49, not negative 49. And when you take the square root of 49, that does equal 7. So it does check out. You want to make sure you always do check things because there are times, look, you may get an extraneous solution, meaning why or how. Well, let's say right here, instead of positive 48, let's just say that our answer was negative or negative 40. Let's just say it was 48. And you end up with 1 minus 48. Okay. Right here, this ends up being negative 47. And remember, the important concept that I want you to realize here is this. If you go back, can we have an answer with a negative number under the radical? You can't. Okay, it doesn't work out. It's imaginary. So then we would have no solution in this problem. So therefore, it is important for you to check things. Okay. All right. So let's say on number 2, right here, we have the cube root. Well, the opposite of cube rooting is to cube each side. So that's what we'll start off with. And then so this now will become 5x plus 1. And then remember, this is negative 4 to the third power. When you plug that into your calculator, you should always put parentheses, okay? And negative 4 to the third power right here ends up being negative 64. We just go about solving it out now. We got subtract 1 to both sides. We got ourselves negative 65. Divide both sides by 5. And you should have x is equal to negative 13. Check your answers. It all works out. Okay, but once again, you should check your answers. For the sake of time, I will skip that here. Next up, let's take a look at number 3. So remember, one of the first steps should be to isolate the radical. So we could do a few things to move things around. Remember, I start off and I said you should add or subtract as the first step. So what I want to do first is let's go ahead and subtract 6 to both sides. And then we end up with 1/4 times the 4th root of 2x is equal to 4. After that, let's get rid of this 1/4. And in order to do that, the reciprocal of 1/4 is 4. So we'll multiply both sides by 4 right here. And now we have the 4th root of 2x is equal to 16. So we did a bunch of stuff before we could even get to what we would say is step 2, right? We got the radical by itself, but we had to do 2 separate steps, right? And now the opposite of the 4th root is to take it to the 4th power, both sides. And so now we have 2x is equal to, and 16 to the 4th power, 65,536. All right, and then lastly, we divide both sides by 2, and x is equal to 32,768. All right, so we're going right through this. Or as you do the homework, or you need to go back and try to look at what we did here in these problems, pause it, rewind it, rewatch some of the stuff. All right, now we get a little more tricky. Let's take a look at number 5, or things get a little more complicated. How about that? We know right here that, look, if I want to get rid of my radical, right, I see that it's already by itself. Let's get rid of it. That means we need to square both sides. Don't forget, this is x minus 7 as a package. So I'm going to put x minus 7 quantity squared. And then now what you're going to have to do is expand the x minus 7. Okay? Meaning this. You're either going to know the pattern. Remember, we talked about those special patterns in chapter 4, or FOIL it out. X minus 7 times x minus 7. Write it out to get your answer. Okay, so you're going to FOIL this out. When you do FOIL this, it becomes, or x squared, outer and inner, is going to be minus 14x plus 49. All right, so now we come to this crossroad. The thing is, I have myself a quadratic function because I have x squared. So getting x by itself doesn't really work because it's not just x squared and a constant. I've got this whole equation thing right here. So hopefully you realize that the best thing for us to do next is to set this equation equal to 0 to help us solve. Let's do that. I've got x squared. I'll subtract x to both sides, and I'll end up with negative 15x. And then I will add this 5 to both sides to end up with plus 54 is equal to 0. Remember, at this point, you have several options. You could factor, you can complete the square, you can use the quadratic formula. Factoring is probably always the best situation and case. It would be a lot easier, save you some work and heartache. So remember, factors of 54 that add up to negative 15. I think, what are factors of 54 that add up to negative 15? How about this? X minus 9, x minus 6. Multiplying the two together, that gets me 54. Adding the two together gets me negative 15. So we go ahead and solve things out, set both binomials equal to 0, and then you can go ahead and solve it out. And when you do that, x is equal to 9 and 6. But for you guys, please show your work. All right, there you go. Let's take a look at another example here. On number 6, let's just start it off. Okay, we got the cube root. So what we should do here is take both sides and cube things. So you end up with 486 minus 27x to the third. And then right here, don't forget to simplify it correctly. We learned some of these rules when you have a term raised to an exponent. And this right here, don't forget, it's 3x times 3x times 3x. So 3 times 3 times 3, that's going to get us 27x to the third. And then from here, you're going to go ahead and get x by itself. All right. I think the rest of it's easy. So let's go to number 7. All right. So on number 7, this one's a little different, another different one as well. Now, I want to get the radical by itself, but I have a problem here. If I divide both sides by 4, I end up with a fraction. No one likes to work with fractions. You can, but it's not very pleasant, right? So one of the things that you can do in a problem like this is, let's get rid of the square root, but we have to take this whole term right there, and we're going to need to square both sides. So essentially, you've got 4 rad x plus 1 quantity squared, or right here, times 4 rad x plus 1. Now I see students foiling. Remember, it's not 4 plus rad x plus 1 times 4 plus rad x plus 1. That's not the case right here. So don't FOIL. But when I multiply things out, remember, what happens when I multiply like square root of x times square root of x, or square root of 2 times square root of 2. When we did the conjugate, all those types of problems, we realized that when the radicals are the same, it ends up equaling whatever's in the radical, because this is square root of 4, square root of 4 equals 2. Rad x times rad x is going to be equal to x. All right, so once again, going back to some of the skills that we learned, you should understand that the radical will become itself. So now, what about this? Well, what do I do with the 4 and the 4? Multiply it, and that's going to get you 16. And then rad x plus 1 times rad x plus 1 will get us x plus 1 right there. What about the other side? Now, over here, this is a binomial. So you're going to go ahead and FOIL it out. If it's easier for you, or if you're adept and you know the pattern, first outer inner gets us plus 2x plus 1. I've got myself a quadratic again, so the best practice right here would be to, let's get x, or set it equal to 0. Let me go ahead and change this to 16x plus 16 is equal to all this. And let's get x equal to 0. And so I'll put 0 is equal to x squared. I'll subtract 16x to both sides. So that'll get me negative 14x, and subtracting 16 gets me minus 15. Looks like this is factorable. Factors of negative 15 that add up to negative 14. Let's go x. Looks like minus 15 and x plus 1. And x right here is equal to 15 and negative 1. Don't forget, plug things back in, see if they work out. I'll tell you what, for the sake of time, they do right here. Okay? Next up, let's take a look at, let's look at number 9. All right, so in our problem here, we can get rid of the 2. All right, so let's start off, we'll subtract 2 to both sides, and I got negative 4th root 2x minus 6 is equal to 12. We have the negative out in front, but we can get rid of that. Remember, algebraically, we could divide both sides by negative 1. So now I have the 4th root of 2x minus 6 is equal to negative 12. All right, now let's see what we can do. Let's go ahead. We get rid of the 4th root by raising both sides to the 4th power. Okay, so let's go ahead. I'll raise the left and the right side to the 4th power. And so I now have 2x minus 6 is equal to negative 12 to the 4th power. And that will get us a positive 20,736. Let's get x by itself. We got adding 6 to both sides. And then we will go ahead and divide both sides by 2. And x is equal to 10,371. It looks like it's a good answer. We got our answer. But remember, you got to plug things in and check it. And so this one right here, when you actually plug it into the original equation, it doesn't equal. So that means that this is not an answer, and our actual answer will be no solution. All right, so we have no solution right here. How unfortunate. All right. Last, let's take a look at number 10. So on this problem right here, I've got on one side, I've got my radical and this plus 2. If I subtract 2 to both sides, I still end up with the same problem. Like I still have this like random 2, or it'll be negative 2 lying around. So let's go ahead, we'll start both sides and let's square it. Meaning with this right here, you're going to have to FOIL it out. Okay, unfortunately, you're going to have to FOIL it. Right? If I were to expand it, it'll look something like this. And then that's going to be equal to it's no more radical. It'll just be 3 minus x. So let's go through this quickly. Let's FOIL this out. Remember, when I take my radicals and I multiply it together, it's just going to equal whatever's under the radical or the radicand. First, outer is going to be plus 2 rad x plus 7. The inner is plus 2 rad x plus 7. And then the last is going to be plus 4. So all of this we could actually combine together because it's all the same. And let's go ahead and put x. Let's simplify things out. I got x plus 11 plus 2, it'll be 4 rad x plus 7. And that's equal to 3 minus x. So let's do our best. Let's get x by itself and let's see what happens here. Next up, let's get the radical by itself. So I'll subtract x to both sides. Let's see. No, my work is a little sloppy here. So we'll subtract x to both sides, and I'll end up with negative 2x. And I'll subtract 11 to both sides, and I'll end up with 8 right there. And then 4 rad x plus 7 is equal to 8 minus 2x. And actually, this is negative 8. So let's go ahead after this. Looks like I could divide both sides by 4. So let's divide both sides by 4. And so now I have rad x plus 7 is equal to, remember, we have to divide everything by 4. So this will become negative 2 minus 2x. Let's go ahead after this. Let's square both sides. This is going to be x plus 7 is equal to, and then let's go ahead. We got negative 2 minus 2x, negative 2 minus 2x. So let's FOIL that out. That's going to be 4 first. The outer is going to be positive 4x. Oh, come on. Don't need that. So we got ourselves positive 4x. Inner will be positive 4x. Last will be negative or positive 2x squared, or 4x squared for that matter. What a problem, huh? So let's set this equal 0. We end up with a quadratic, it looks like. So we got, let's rewrite this. We got 4x squared. Oh no, we got ourselves, that should be a 1/2, right? I messed up right there. Looks like we're going to have to go back and do some more work. Oh no. All right, so let's kind of go back a step right here. I'll redo the foiling. It's negative 2 minus 1/2 x times negative 2 minus 1/2 x. I rushed through it. I don't know. I've had the numbers right here, and I misplaced the 1/2. I put that as 2. So let's try this again. So when I FOIL this out right here, we got 4 outer and inner. That'll get us right here. Let's see, plus 2x. And then we have ourselves plus 1/4 x squared. All right, FOILing this out. First, outer, inner, because -2 times -1/2 will get us positive x. So let's rewrite things out. So I got x plus 7 is equal to, and then let me go ahead. I'll rewrite this in a better order. 1/4 x squared plus 2x plus 4 will get, we got to set this equal to 0. All right, so let's set things equal to 0 right here. And we'll end up with 0 is equal to 1/4 x squared plus x, and then subtracting 7 to both sides, we'll end up with plus 3. Or sorry, looks like minus 3. You're saying, well, this question looks pretty hard and difficult. It is, but there's a reason why I'm doing this problem. Let's go take a look right here. Let me move this up, erase some of this. I've got that 1/4. That kind of sucks. So what we could do is get rid of our fractions. Let's multiply both sides by 4. Okay, so I'm going to do that next. We'll multiply both sides by 4. 4 times 0 is still 0. 0 is equal to x squared plus 4x minus 12. And then look, now we got ourselves a nice quadratic. We can go ahead and now factor this out, and this will factor into x, let's say plus 6x minus 2. And so in the end right here, we have our answer is going to be x is equal to 6. Or sorry, let's try this again. What am I doing? X plus 6. Yeah, so we got x plus 6, so that x will now be equal to -6. And then we have ourselves right here, positive 2. All right, so now, remember, we want to make sure that things work out. Not everything works out right here. Because let's plug in what -6 into here, into this equation. And what's -6 plus 7? That's -1. Remember, we said we can't have negatives. We can't. So therefore, on this problem, we do have ourselves an extraneous solution. And the only answer that we do have that works out right here will be 2. All right, -6 is extraneous. When I plug that into the original problem, -6 plus 7 is -1. We add -1. It's imaginary. All right, so it's not going to work out. That's why you do need to check your answers. That's why I went over this problem. And it's pretty complicated. Fun times. All right, so there's 5.4a. We'll come back and finish this up in 5.4b.